Hey Mr. Wellman, this is Jonas. I'm reporting on the extra credit number 1, which is shown here. By looking at this problem, I decided it'd be best to make FB here, right at the hip, the pivot point. And then I proceeded from there. I did my work on my notebook. So I'll just walk through it. So here it is. So I just noted a few things here. So FB is the pivot point. WB and W box are CW. So from here they rotate this way, which is negative. F of B is CCW, which is positive. Just something to note. So from there, I used the perpendicular lever arm to find F of B, which is all given in the diagram. From here, where the pivot point is to the elbow, is, so I converted from centimeters to meters, which is 0.35 meters, and then I multiply that by mg, which is the mass of the upper body times gravity, which is 9.8, plus the distance from the pivot point to the box, center of the box, which is 0.500 meters, also times mg, which is 30 kg, the mass of the box, times gravity. So then when I set it up like that, and then we also have the height, which is about 0.0800 meters times FB. So I solve for FB and I get 4,195.6 newtons. So I just rounded that to about 4,200. And that's the answer that I'm getting for the first one, which is calculate the magnitude of the force FB in the back muscles that is needed to support the upper body, plus the box, and compare it with this weight. So comparing it with his weight, I did that down here a little later. So F of V I found was 4,660 newtons divided by WUB plus W box. So the weight of the upper body plus the weight of the box. And how I found that is here. So the weight of the box would be, the mass of the box is 30 kilograms times 9.8 meters per second squared. And the same thing for the weight of the upper body. And I get 5.59. Okay, part B is saying calculate the magnitude and direction of the force FV exerted by the vertebrae on the spine at the indicated pivot point. Okay. So here what I did was, so this is looking at, so we have to set it up where the net force is 0. So I start with the y component first. So FVY minus the weight of the upper body minus the weight of the box minus F of B. Sine 29 is equal to 0. So I am solving for FVY. And then I have WB plus W box. I get 833 newtons, which I've solved here on the side, plus the 4,200 newtons and sine 29. And then when I do that, I get F of Vy equals 2.87 times 10 to the 3 newtons. This is about 2,870. I also solved for the x component very similarly, and I got 3,670 newtons. Then to solve for the magnitude, since we already have f of vx and f of vy. To find f of v, all I had to do was use the Pythagorean theorem. So take the square root of f of vx squared plus f of vy squared, and I've set it up here, and that will give you f of v, which is about 4,660 newtons. And then to find the direction of f of v, that would be theta equals the inverse tan of 2,870 divided by 3,670, which gives you about 38 degrees. And this is just the ratio from earlier.